Hello everyone, welcome back to Smart Trends YouTube channel. Today we are going to see CodeChef Starter 189 D4 solutions. My name is 𝗟𝗲𝗃𝗃𝗃. Let's deep dive into the first problem. Okay, let's look at the first problem in the CodeChef contest, that is pizza party. So the problem statement is something like chef is hosting a pizza party and has invited A boys and B girls. Don't forget to include a chef himself, he is a boy. Few main things to remember that okay, chef is hosting a pizza party where he invited A boys, B girls, and he has to include himself as well, and he is a boy. It is known that boys eats 4 slices of pizza while a girl eats 3 slices of pizza. Further, a single pizza slice comes with the 8 total slices of pizzas here. Okay. So it is also given information that a boy eats 4 slices of pizza while a girl eats 3 slices of pizza, and it is also given that a single pizza comes with the 8 total slices. How many pizzas does the chef require to ensure nobody remains hungry? It is fine to waste some of the foods. It is clearly given that it is clearly fine to waste some of the foods. I hope the problem statement is clear. Let's look at the sample output as well for more clarity. So here given that there are 2 boys, there are 0 girls, and if I include chef as well, so total there are, I can say, 3 boys are there. 2 plus 1 is for the chef himself, and the number of girls is going to be 0. The number of girls are going to be 0. Now, how many total slices are required? As each and every boy will eat 4 slices of pizza, so can I say that it's going to be 4 into 12. Now, to make sure that no one remains hungry here, we need to order how many pizzas? In one pizza, we know that we'll be getting 8 slices, and total requirement of slices are 12 here. So can I say that 2 pizzas are required? You require 2 pizzas here. Okay, you require 2 pizzas here. I know that, yeah, here 8 slices will be there, and here 8, like remaining 4 will be wasted, but it's clearly given in the problem statement that it is okay, it is fine to waste some of the food here. So total number of pizzas required are 2. If I see the second input here, if we look at the second sample input here, boys are 0, but if we include chef, it's going to be 1, and the number of girls are going to be here 4. So total slice required by the boys, it's going to be 4, and the slices required by the girls, it's going to be 4 into 3, which is nothing but 12. And if I add 4 plus 12, it's going to be 16. Now, to make sure that no one goes hungry, how many pizzas are required? Again, 2 pizzas would be sufficient. 8 slices in the first pizza and 8 slices in the second pizza will be sufficient so that no one will be hungry here. How do we solve this problem? Simple, right? You get the count of boys, whatever we were doing, you get the count of girls as well, requirement of number of slices, and for that, if I get 16 here, I need to find out for 16 slices how many pizzas does the chef needs to buy. I can simply divide it by 8. It's going to be 2 here. Now coming to here, it's going to be 12 by 8. It's going to be 1.5. So even though there is like 1 more extra slice also needed, you need to order 1 more pizza. So always we need to take a seal here. Can I say that always you need to take a seal here? Here also you need to take 2 pizzas basically. Okay, let's try to code up the same thing. Okay, so this was the pizza party problem. Let's try to first read the input here. Boys and the number of girls we need to take. We'll be reading the values of boys and girls here. In the boys, we need to include chef as well. So I can say that boys equals to boys plus 1. Now, slices required by the boys. What is the total slices that will be required here? Total slices will be boys count into 4 plus girls count into 3. That's it. Now these many slices are required so that no one goes hungry. How many pizzas does the chef require to order here? That will be getting by, as I told you, by 8 here. So I can say that if total slices, you can do with the seal thing as well, and here I will using other technique. If total slices mod 8 not equals to 0, that means we need to order one more pizza here. So our answer is going to be total slices by 8. Our answer is going to be total slices by 8 here plus 1, because as it's like completely not, something is left over, so you need to add plus 1 for that. And if it's equals to 0, you can simply order total slices by 8 pizzas. Now let's try to run and see if our code is correct. Yeah, submit it as well. Let's submit it as well. Done. That's it. Okay, let's look at the second problem from the contest, that is distinct to subarray. So here the problem statement says that an array is called good if it has exactly 2 distinct elements. Okay, for example, if I take this array and this array, there are like only two distinct elements, 1 and 2, and here the distinct elements are 5 and 3. These are good, but if you look at this array or this array, these are not good because the distinct number of elements are 3 here and the distinct number of elements are 1 here. So array is called good only when it has exactly 2 distinct elements, not less than that nor more than that. You are given an array of n elements and you need to find the length of the shortest possible good subarray of A. Okay, if no good subarray exists, we need to print -1 instead. Okay, I hope the question is clear. First thing that you need to remember, a array is called good only when it has exactly 2 distinct elements, not less than 2 or greater than 2. Only 2 distinct elements. Array with the 2 distinct elements are known as a good array. Here you are given a array of n elements. You need to find the length of the shortest possible good subarray of A. If it's not possible to find any good subarray, we need to print -1 instead. Now let's look at here sample input for more clarity. First input, you are given the size of the array and these are the array elements, that is 5 and 3. Can I say that this is the subarray which is a good here? This is a subarray which is a good subarray here, and the length is 2. The length is 2. That's why your answer is also 2 here. Now here, where the array element is only 1 here, is it possible to form or is it possible to get the good subarray here? Not possible. Whenever it's not possible, -1 is your answer. Next, here if I look at, this is also a good subarray. Can I say this is also a good subarray? There are like multiple answers here. I can say that the subarray starting with 775 is also good. The subarray 7755 is also good. 75 is also good. And 755 is also good here. All these subarrays are good subarrays only. All these subarrays are good only. Now, when all of them are good, why we are taking answer as 2 here? Why our answer is 2 here? Because this is the shortest length subarray, which is a good subarray as well. Here, that is the thing we need to find, right? Find the length of the shortest possible good subarray of A. And this is the shortest good subarray of array A here. And if we look at the constraints here, constraints are not very large or something. Constraints are like number of test cases can be 100 maximum. Array length can be maximum 100 and the array elements can be, again, it can be maximum up to 100 only. So we can generate all the subarrays and we can check, are we having any good subarray? Whenever we found any good subarray, we can directly get the length of that, and we will always try to store the minimum length. As we are having the low constraints here, as we are having like very small constraints, you can write the brute force code going for each and every subarray, generating all the subarrays, generating all subarrays, brute force way, that is generating all the subarrays and check how much time the generating the subarray takes? Basically n square time. So here t into n going to be 100 10 square into, and here I can say 10 square whole square here. So total 10 square into 10 power 4, 10 power 6. Our code is going to work as smoothly. This solution is going to be accepted. Brute force code, we can try generating all the subarrays. Okay, let's directly look into code. But before we jump into code or something, let's suppose, how will you know that there are two distinct elements here? How do you know that there are only two distinct elements here as well? Two distinct element. See, to solve this problem, there are other methods as well. You can use binary search, sliding window as well. But as the constraints are smaller, we are going with the brute force generating all the subarrays here. How do we know that there are two distinct elements here, two distinct elements here? There can be other brute force method, but one thing can be, you can use a set here. You can use a set, insert all the elements of the subarray into set here. In the set, it's going to be 7, 5. Whenever the set size is 2, it is a valid subarray. Yes or no? So we can use a set for finding out the number of distinct element in the subarray. I hope it is clear so far. So let's directly jump into the code part. Okay. So this was the problem that we were discussing. Let's try to first read the inputs here. Number of test cases are given. You are given the size of the array. Let's create an array of size n. We'll be reading each and every value of the array. Going to each and every subarray. We will create a unordered set. I will say that I will insert set.insert array of j if set.size equals to 2. Okay, if it's greater than 2, we need to break from here. If that is not the case, like if the set.size equals to 2, we'll always update our answer. So we need to have our answer variable as well. Let's say initialize to int max here, and I will say that answer equals to minimum of answer comma length of the subarray. Can I say the length of the subarray is going to be j minus I plus 1? I will try to always take the minimum of the answers or the length of the subarrays. At the end, we need to print the answer here. Okay, one more thing. Whenever we get the, we are not able to find any good subarray, we need to print it as -1. You can use the, for that you can use the ternary operator, or you can write if else conditions as well, saying that if answer equal to int max, you print the -1, or else you simply print the answer whatever you are getting. That this much should be sufficient, or you can write in a single line as well. That is also going to work. That's it for the second solution. Let's discuss the third problem of the contest, that is nutrition cost. So in the problem statement, it is given that there are total n different food items, each providing an essential vitamin AI and it will be costing you BI. There is an integer parameter C as well, which represents the value of a single vitamin to you. So basically, till now the question statement is something like there are n food items are there. Each provides an initial essential vitamin AI to you, and it will cost you BI. And there is some another parameter as well, that is C, which represents the value of a single vitamin to you. Okay. You will buy some of the food items to maximize C into X minus Y. Here C represents value of each vitamin here. X represents, okay, basically it is given that C multiplied by X minus Y, where C represents, as I told you, C represents the value of the single vitamin. X represents number of distinct vitamin eaten. What is the number of distinct vitamins you have eaten? And Y represents the total cost of the all food items that you have taken. Okay. Find the maximum possible value. It is also, okay, it is also possible to buy no foods item at all, in which case your answer will be simply 0. Okay, we have to maximize the possible value, that is this value. We have to maximize this thing. It is also possible that we don't buy any food items at all, in which case our answer is going to be simply 0. Input format, let's look at the input and output format as well. First line will contain the single integer t denoting the number of test cases. For each and every test cases, there will be multiple lines. First line of each test case will contain two things, n and c. N represents the number of food items, c represents the value of the vitamin. And next two lines will be A array and the B array, where A array represents the type of food you are taking or the type of vitamin you will get, and the BI represents the cost of each and every food item that you have taken. Printing output format here, maximum possible value of C into X minus Y, as explained in the statement. Now, let's go through the sample input and output for more clarity. So this is the N is nothing but the, I can say, size of the array or the number of vitamins here. This represents C, cost of, or the, not cost, value of each and every vitamin that you have taken. That will provide you the value of C. AI represents the type of vitamin here, and this represents, BI represents the cost of each and every vitamin. So here it is said that we can take all the three vitamins here. If I am taking three vitamins, first vitamin with the cost of 1, second vitamin with the cost of 1, and the third vitamin with cost of 1. So the formula of C into X minus Y, the value is going to be, C value is 5 here, 5 into, this X is nothing but, what is the meaning of X here? X represents number of distinct vitamin you have taken. So what is the distinct vitamins I have taken? One vitamin of type 1, one vitamin of type 2, one vitamin of type 3. So total the number of distinct vitamins are going to be 3. And cost for taking this vitamin is 1, cost for taking this vitamin is 1, and cost of taking this vitamin is 1. So total 3. And if I find out, it's going to be 15 minus 3, which is 12. And we cannot generate more value than 12. That's why our answer is going to be 12 for this test case. Now, if you look at the second test case here, I will erase the first one. And now if you look at the second test case, this is the C value, meaning that value if you take any vitamin that you will get. So again, vitamin 1, you will have the cost 2 you will take. Vitamin 2, it will cost you again 2, and the vitamin 3 will also cost you 2 here. Now, if you take the vitamin here, if I take, let's say if I am taking all 3 vitamins here, if we take all the 3 vitamins, can I say that it's going to be 1 into number of distinct vitamins that we have taken, the value of C into X minus Y, it's going to be 1 into 3 minus cost of taking these vitamins, it's going to be 2 plus 2 plus 2. So 3 minus 6, can I say minus 3? Minus 3. If you take even 2 vitamins here, again same thing, if I take only 2 vitamins here, can I say that it's going to be 1 into 2 minus 2 plus 2 here, and it's going to be 2 minus 4, it's going to be minus 2. Okay, if you take even a single vitamin as well, let's say I'm saying that I will not take the vitamin 2 or vitamin 3, I will take only vitamin 1, then this value is going to be 1 into number of distinct vitamins that you are taking, only 1, this type, and the cost is going to be 2. So it's going to be 1 minus 2, which is equal to minus 1. Now, if you even though you are taking only even though you are taking only one vitamin, or you are taking two vitamins, or you are taking three vitamins, your answer is always negative. So can I say that it's better I will not take any vitamins here? I will not take any vitamins here. Then if you don't take any vitamins, your this value is going to be 1 into 0. As we have not taken any vitamins, it's going to be 0. Entirely, basically, it's going to be 0 only. 1 into 0, 0 minus 0, 0. That's why for the second test case, your answer is 0 here. Now, let's look at for the third test case, and things will be like even more clear with the third test case here. Okay, things will be like even more like much more clear when we look at the third test case here. The value of C that is given to us is 6 here. There is a vitamin with 3. There is a vitamin 3 which will cost you 7. There is a vitamin 4 which will cost you 4. Vitamin 2 will cost you 1. Vitamin 2 will cost you 1. Vitamin 3 will cost you 8. Now, see, if you try to take all the vitamins here, then your cost is going to be C into X minus Y, right? So here cost, like the value that we will be getting is 6 into number of distinct vitamins, 1, 2, 3. Okay, so there are 3 distinct type of vitamins here. So 6 into 3 minus, I need to add everything as a cost here, 7 plus 4 plus 1 plus 1 plus 8. Which is going to be 18 minus, okay, 11, 12, 13, 21, 21, and it's going to be minus 3. Okay, so if I am taking all the vitamins, we are getting the value of minus 3, but we need some better answers here. So can I say that I will not take all the vitamins here? If you need a better answer, I will not take all the vitamins here. Let's take something in particular. See, I will give you one more hint here. I'm not sure if you have observed so far or not. Let's suppose if there are 2 different vitamins, okay, let's suppose there are only one kind of vitamin, that is 3 and 3. Let's suppose this is a test case where you are having where you are having the vitamins 3. Let's suppose this is costing you 5 and this is costing you some 7. Okay, this is costing you some 5, this is costing you some 7, and the value of C is some, let's say, 10. Here, is it better to take both the vitamins here, or it's better to take only single vitamin of that type? Guys, are you understanding here? That is it always better to take only one vitamin of that type, or is it better to take all the vitamins of that type? Here, there are 2 vitamins of type 3. Is it better to if I am taking both of them, or is it better if I am taking only one of them? See, if I take both of them here, can I say that your answer is going to be 10 into 1 minus 5 plus 7, and it's going to be 10 minus 12, which is going to be minus 2. Not a better answer, right? Negative you are getting. But if I take only one of them, and in that one of them as well, which one should I take? Which is costing us 5, or I should take which is costing us 7? As I need to maximize our answer, can I say that it's always better if you take this one with the minimum cost? And if you take that, it's going to be 10 into 1 minus 5. 10 minus 5 is going to be 5. Your answer is going to be 5. So it's always clear that whenever multiple vitamins are there of similar type, we need to take only one of them. And in those as well, one of them, you need to take only with the minimum cost. We need to take with the minimum cost. I hope it's clear so far with this example. So can I say that out of these many vitamins that are given to us, I will take only one of them out of 2 vitamins of type 3, and in both of them I will take only this one. Now there are 2 vitamins of type 2. Which one I will take? If I take the first 2 or the second vitamin, both of them are costing us 1. So it's completely fine. I can take any one of them. 4 with the 4 here. So can I say that from my picture, this thing is already gone now? Now here as well, which one to take, which one to not take will also depends upon that. If you're taking that vitamin, is it contributing positive value to your answer or is it contributing negative value to your answer? It will also depends upon the, if you're taking one particular vitamin with that cost, will it contribute the positive value to your answer or will it contribute the negative value? How will you know that? We know that if you pick any vitamin, you will get the value of C and it will cost you Y, and X will be incremented by 1 because you have taken that one distinct vitamin. So can I say that you will always take the vitamin if you are getting that positive value from there? So if I look at here, if I look at the example here where C is equals to 6, C equals to 6. Now C into X minus Y, right? If I am taking this one, if I am taking this vitamin here with the vitamin as 3 and the cost as 7, can I say that it's going to be 6 into 1 minus 7 and it's going to contribute the value of minus 1 to it? So I will not take this one. I will not take this one. Let's see with the second one as well. 4 with 4. So can I say that it's going to be 6 into 1 minus 4 here? And you see that you are getting the value of 2 from there. If I'm taking that vitamin, you are getting the positive value 2 from there. So you will take that. Now coming to this one, should we take this one or not? It's going to be not 2 into 1. C value is 6 here. So 6 into 1 minus 2. Yes or no? Oh, sorry, not minus 2, minus 1. 6 in. Yes or no? 6 into 1 minus 1 here. And how much you will be getting from here? Nothing but 5. So can I say that again we are getting the positive value from there? And if I add both of them, it's going to be 7. That's why our answer is 7 here. So I hope till now you observe few things. Whenever there are multiple vitamins, I will write down everything in a point manner. First one, whenever there are multiple vitamins, take only one vitamin of that type with lower cost, Again, you need to decide, do you want to take that vitamin or not? Once you do this one as well, you need to decide whether you take that vitamin or not. Based on decide to take particular vitamin or not, decide to take particular vitamin or not, based on what kind of value you are getting. Are you getting a positive value? Then you will take it. If you are getting a negative value, you won't take it. Decide to take particular vitamin or not based on value we get from it. Based on value we get from it. So first challenge here is that how will you get these 3 values? And once you get these 3 values, vitamin 3 with the cost of 7, vitamin 4 with the cost of 4, vitamin 2 with the cost as 1, then you can see that, okay, if you're getting a positive contributions, you will add into the answer or else you won't add into the answer. For that, to get that positive contribution having, if there are multiple vitamins as well, you will take only single with the lower cost. There are multiple ways, like to do so, there are multiple ways. But if you look at the constraints here, the constraints are very small here. Again, the test cases can be large as 100. Number of elements can be in the array can be only 100 here. Again, BI values and everything can be up to 100 only. The constraints are smaller. So if the constraints are smaller, what I can do is that we can create a what I'm thinking, like you can do in another way as well. But what solution came to my mind is that, okay, we can create a maybe some another array, that is, let's say, some temporary array. Okay, you will create a temporary array where you will have all the like temporary of size 101 until 101. So the last index is going to be 100. And initially everything is value, like each and every index value is going to be maximum int max. Basically everything is going to be int max here. Okay, everything is going to be int max. Now I will come here, I will see that vitamin 3 with the cost of 7. I will come here, I know that it's a better answer, I will update it with 7. Okay, I will update it with 7. Next I will go to the next index, vitamins of type 4 with the cost of 4. Yes, it's a better answer, so I'll add it. All these things we are doing for getting these ones. Okay, to get these things we are doing. Now 2 with 1, 2 with the cost of 1, 2 with the cost of 1. Again there is one more 2 with the cost of 1, not better, so it's better to have vitamin 2 with the cost of 1 itself. No, vitamin 3 with the cost of 8. When I go to the vitamin 3, I know that I'm already having something with the better cost here, 7. So I will not update here. And now what is left here, will iterate on this. I will take only values which are not int max here. I will take only values which are not integer maximum here. I will take that. I will go here, positive contribution, not positive contribution, positive contributions, and I will add into the answer. I hope the logic is clear. Okay, let's code it up. Sample input as like NNC values, then second line given you is the array A and the second array B, which is the cost of each and every vitamin that you are taking. So here it's going to be like, we need to read the N value here, C, N and C, A array of reading the A array values, creating a B array of size N, B of I. No, as I told you that, okay, we can create a temporary of size 101 to store the distinct vitamins with the minimum cost. You can do in that way by directly creating a size of 101, or you can create a size of N as well. Anything works here. Anything that you create is going to work here, not an issue. You can do in both of them, in both the ways you can do. So I can say that, okay, let's have another temporary array. Okay, let's have another temporary array of size 101, or I can have a vector here, temporary of size 101, initially everything initialized to int max. Or I can say here, and I can say here that, okay, temporary of whatever the A of 5 index is there, I need to have minimum of whatever the previously we are having and whatever we got just now, like B of I. Okay, which one is better for that particular vitamin, like the already cost that we are having or the cost that we got just now, is that one is better. Now once that is done, we will have our answers as well. We will start finding our answers. We'll go to each and every value here, I less than 101. I will iterate on the temporary array, and I will see that if C into x minus y, is it giving you the positive contribution or not. So if I can directly say if whatever your C is there, if C right, yeah, if C is greater than temp of I here, I know that you're going to get a positive contribution, and you will say answer plus equals to, what is that positive contribution? Nothing but C minus temp of I here. That's it. At the end you need to print the answer here. That should be sufficient if we are not making. Okay, that's it for the third one. Okay, let's look at the fourth problem of the contest, that is create binary strings. And the problem statement is something like you want to make a binary string s of length n and you will be paid according to the following rules. For each occurrence of subsequence of 0 in s, you will be paid a coins. 0, you will be paid a coins. For each occurrences of the subsequences of 1 in s, you will be paid b number of coins. For each subsequences of 0, 1 in the string s, you will be paid c coins, c number of coins. And for each occurrences of subsequences of 1, 0 in the string s, okay, 1, 0 in the string s, you will be paid d number of coins. Okay, you have to create a binary string, and this is how you will be paid. Note that occurrences does not need to be contiguous. Main important point here, and they have highlighted as well. Note that the occurrences does not need to be continuous here. Subsequences, they are saying. I hope you know the meaning of subsequence. If I take this string here, if we take this string 0, 1, 0, 1 has 3 occurrences of 0, 1. You have 3 occurrences of 0, 1 here. How we are having 3 occurrences? You are having this as 1 occurrence, you are having this as second occurrence, and you are having this as the third occurrence. So total there are 3 occurrences of 0, 1 here, not 2. They have mentioned very clearly. Now, thus for the string 0, 1, 0, 1, you will be getting paid something like 2 into a, because there are 2 zeros, so 2 into a, plus there are 2 ones, so 2 into b, plus there are 3 0, 1 occurrences. There are 3 0, 1 subsequent occurrences here, so 0, 3 into c here, plus what is the occurrence of 1, 0 here? Can I say only one occurrence is there of 1, 0? So it's going to be 1 into d here. I hope the question is clear. Now, if you look at like what do we want actually as the input? As the output here, you want to maximize the number of points you get. We don't have to even print the sequences like subsequences here. You just have to print what is the maximum number of coins you can get. Find the maximum value. Input format, you will be given the single line t denoting the number of test cases. For each and every test case, you will be having 5 things. Length of the binary string, n is nothing but the length of the binary string, I would say. A, B, C, D. A is nothing but the count of occurrences. Like if you are having these many occurrences of 0, you will be paid that many occurrences into A. Occurrences of 1 into B. Occurrences of 0, 1 into C. Occurrences of 1, 0 into D here. Again, the constants are not like very large or something. Constants are like very small. If I look at the first example, if you look at the first sample input here, can I say here this represents n, this is represents A coin, B coin, C and D. Okay, n as 2 is given here, A as 2 is given, B as 1 is given, C as 3 is given, and D as 4 is given. So can I say that how do you get the maximum coins? You need to make a binary string of length 2 here. Okay, you can make it as, what are your options here? What are your options here? Can I say that your options are 0, 0. You can make it as 0, 1. You can make it as 1, 0. You can also make it as a 1, 1. If you are making the binary string as 0, 0, can I say that it's going to be 2 zeros? So 2 into A, that is 4. Here it's going to be 1 into 2 plus 1 into 1 plus there is a sequence of 0, 1 as well. So it's going to be 1 into 3. Total 2 plus 1, 3, 3 plus 3, 6. If you look at here, this one, it's going to be 1 into 1. Just a second, here also, okay. Here it's going to be 1 into 2 plus 1 into 1 okay, plus there are no sequences with 0 1, there is a sequence with 1 0, so it's going to be 1 into 4. Can I say total? It's going to be 7. Similarly here as well, 0 into 2 plus it's going to be 2 into 1 plus there are no sequences of 0 1 or 1 0, so it's 0 into C here plus 0 into D here, and the total answer is going to be 2. Now out of all these 4 6 7 and 2, which is maximum? Can I say that the maximum is 7? That's why your answer is 7 here. If you look at the output, your answer is 7 here. Same thing you can try with the this input as well. N as 4, A as 2, B also as 2, C as 1, D as 1. In a brute force way, you can try all the possibilities here. If there is a brute force way, you can try all the possibilities. 0 0 0 0. What is the cost, what is the maximum number of, what is the coins you will be getting? Then you try with 0 0 0 1, what is the number of coins you will get? But if you follow this way to generate all the possible ways here of length 2 of n equal to true here, can I say it is nothing but 2 power n, and here it's going to be 2 power n here as well. There are going to be total 2 power n combinations of coins you can pick. Yes or no? Total 2 power n. And if you look at the constants, 2 power n is not going to work. N is 100 here, so that solution is not going to work. But in a brute force way, you can try. So now let's look at, in a greedy way, how can we get maximum number of coins? Like which sequence can give us the maximum number of coins here? Okay, so how do we optimize this and everything? But I hope you understand that if you're having the value of n is anything, maybe 2, maybe 4, or maybe 100, whatever the value of n is there, can I say that if your string is some 0 0 1 0 1 1 0 0, something like this, can I say that your answer can always be number of zeros into A plus number of ones into B? Yes or no? I hope it is clear so far, like number of zeros into A plus number of zeros into B. Yeah, I know there are few things further as well. Number of this combination into C and number of combination of 0 1 into C plus number of combinations of 1 0 into D here. But I hope this part is clear. Whatever your answer is there, it's always going to be Z into number of zeros into A plus number of ones into B. This combination and combination of 0 1 into C and the combination of 1 0 into D. Let's say you are given values of C as some 7 and the values of D as 5. I'm talking about the case where C is greater than 5. Okay. Oh, sorry. C is greater than D here. I'm all talking about the case when C is greater than D. And if I take this string itself, I know that whenever the cost of C is greater than D, it's always better to make 0 1 pairs. Yes or no? It's always better to make this 0 1 pairs because the value of C is greater than the value of D. These pairs is also fine, but they will give you only the cost of 5 here. But if you had your string something like 0 1 here, you would have gotten the value of 7. But here you are getting the value of only 5 coins. So can I say that whenever the value of C is greater than D, it's always better that we are making the pairs of 0 1 than 1 0. And if you try to convert all the 1 0 pairs into 0 1, can I say that it's better that your substring, whatever the string is there, it should look like 1 2 3, so all the zeros are at the start and all the ones are at the end. So total 1 2 3 4 5 6. 6 zeros are there at the start and there are 3 ones at the end. Now you can comfortably make each and every pair here. 0 1 pair, 0 1 pair, 0 1 pair. Each 0 will be able to make a pair with each ones here. Now, how many total such pairs will be there? Can you guys tell me? if I am having a string something like this, how many pairs of 0 1 will be there here? How many pairs of 0 with 1 will be there? Can I say that nothing but count of 0 into count of 1 here? Z into O will give you, like, number of zeros into number of 1 will give you the count of number of pairs, like number of 0 1 pairs here, and the cost is going to be C. Will there be any 1 0 pair here? No, there won't be any 1 0 pair here. But let's suppose there is another case as well, where D is greater than C. In that case, can I say that you will be converting your string into something like 1 1 1 0 0 0 0 here as well, or something you will convert your string something like this, because we know that the cost of D, or the number of D's are greater, like the coin you will get, the value of D is greater than value of C here, and you can make a pair something like this 1 0 1 0, and here also it's going to be number of zeros into number of ones only, and the cost is going to be D here. I hope that is clear so far. Now, can I say that it also now depends upon the, like, if you have cleared so far, like it also, so let's say there are total k zeros. There is a case, let's say, where we know that there are k zeros in string. If there are k zeros in the string, how do you get the maximum number of coins out of there? Can I say that your answer is going to be k zeros? We know that, so k into a plus, if there are k zeros in the string length is some n, can I say that the number of ones are going to be n minus k here, and the coin you will be getting from ones here, it's going to be n minus k into b plus. Now you are having two options, either C is greater than D, or you are having one more option where D is greater than C. When C is greater than C is greater than D, can I say that you will be getting the number of coins as k into n minus k, like number of ones into number of zeros into C here. This can be one of the possibility. What can be another possibility? Can I say that one more possibility can be D is greater than C. In that case, this thing will be same, and here it's going to be k into n minus k into, when D is greater than C, when this thing is there, can I say that it's going to be k into n minus k into D now? If you understood so far, no, entire solution will revolve around that. We'll have a loop with 0 number of k's, then we'll be seeing with the 1 number of k, then we'll be seeing with 2 number of k's in the binary string, then we'll be seeing with the 3 number of binary string. So we'll be going from 0 to n. We'll be seeing that if you are having 0 number of zeros in the string, if you are having 1 number of binary strings, what is the answer you are going to get? Maximum of this one and max of this one as well, like max of entire thing. Whatever the maximum number of coins you can get, you will be storing in the answer. Let's try to code up the same thing in the editor as well. Okay, this is the problem. Let's code it up. Input format, you are given n, you are given the a, you are given b, you are given c, d you are given. So we'll read all the values here of a, b, you will read c and d. Now, as I told you, we'll be iterating on all the values of number of zeros here, starting from 0 to less than or equal to n. We need to have the answer variable as well. We'll be having initial value of answer as 0. Now, you will say that answer equals to max of answer comma. Okay. If I'm having 0 number of zeros in the binary string, can I say that it's going to be like, if I am having I number of zeros in the binary string, it's going to be I into A plus number of ones, then it's going to be n minus I into B plus, then it's going to be I into number of zeros plus, like, into number of ones here into C. This can be one of the possibilities, or another possibility can be D is greater than C. So only thing that will change is D here. Once that is done, you will simply print your answer here. Let's see if you're getting the right solution. Okay, 712, yeah, 86950. And it is accepted. That's it for this problem.
Thank you for watching this video. If you have liked this video, subscribe to our channel. See you guys in the next video.